Giuseppe De Mauro is the chief architect of Pubmatic. We invited him up here to share a few of his stories about the Pubmatic infrastructure and things that he's learned about scaling systems in the last years of his life. Yeah. He said he just came back from where, Bangalore?
Yeah, it was no. We actually have our development team is in India, in Pune. That I think the guys from Bangalore knows, everyone else don't. And I'm gonna go on another trip, so I couldn't prepare any large presentation. And I think what Gianpaolo did, it's covering pretty much also whatever I want to see myself. So thanks Gianpaolo for taking care of that, and I think we can go on.
Excellent.
On this back and forth, yeah.
So why don't you tell us a little bit about some of the high-level components that you've chosen at Pubmatic and why?
Yeah, okay, so Pubmatic has a history of 7 years of development, so things moved, and I'm pretty sure that each of you had a similar history. Whenever you're starting a new company, you never know where you're going to get. So what happens is that the story changes. So you start with solutions that are very easy, and then you end up with some solution. It might not be the one you wanted to be with if you knew ahead of time how. Can you hear me actually? Yeah. How the architecture, how the architecture would be, but that is how it works. I think that we came out with something that substantially reflects what I'm seeing in the industry. And if we just knew ahead of time, or if I heard the presentation from Gianpaolo, like if we heard it 6 years ago, I think we could have solved a lot of our problems ahead of time. So it's pretty typical. It's very similar. So we are an attack solution. We are what is called an SSP. So most of the elements are similar to what we are already. So we are running a global company. We are in, I don't know how many countries, probably 30, 40 countries. We're one of the major display SSPs. So we are serving about 3 billion, 4 billion impressions in one day, and that is actually substantial. So the way we do it is that we have, of course, several data centers, and as he described, we're moving also on building our own data centers. We figure out that this is the right solution. And the same was for Amazon. Amazon wasn't actually working. I think is the unpredictability of the latency, the big problem there, besides the cost that really kills you in the long term. If you can buy your own hardware, I believe it's better to go that way. But I believe that not being predictable and the downtime from time to time, East Coast, West Coast goes down, was one of the big problems. So we have 4 or 5 data centers, depending. We're still using one Amazon, and the way it works, we have a typical cluster of ad servers, and then we have a big data crunching with Hadoop, and we have a lot of other services that do the magic. So I guess that here you don't see any news compared to what you probably guys are doing.
Right. So you're using a lot of Hadoop, but then you said you're using HBase for queries.
No, actually it's Hive. Actually, the way it works is that we have a front end that is C, used to be Java, same story, right? So we went from Java to C, and we went for the ultimate performance. And this is a story I've heard every company I've been with, besides one, where we actually stuck with Java because we considered that finding Java developers was easier than finding C developers. But we had to work around, actually, and the big problem, I don't want to jump too much, but the big problem there was garbage collection. So we were very careful on what we were allocating. So allocating object for us was a no-go. So use like native types, try to do this thing as much as you can, because with Java you're going to be sure that once you produce many objects, if these objects get old, get stale, then you're going to end up with minutes of downtime. The system might get stuck, and no one wants to see like a white banner or an empty video, right? So this is what happened. And what we're doing now, we use a C front end behind Apache, very, very common, and we're producing a lot of data. We have a real-time bidding process. It's going to be multi-threaded because we have more than 60 partners in each of our auction. And I hope that these are terms that you guys are going to be common with. Yeah. And we crunch data with Hadoop and Hive.
So with your Hive and Hadoop analytics systems, can you say something about sort of the kind of people and analysis, how long analysis takes, how much of it is exploratory versus sort of common repeated jobs?
Well, we use it for both exploratory and repeated jobs. Repeated jobs mostly could be like analysis that executive finance team or our clients require, and they want to have it daily, and instead of just running queries, because I mean we have I think the size of data is pretty common in this industry. It's hard to do in any regular database. So what we do is that we use this for running. Basically, the way we do, we play some trick. What we do is that since we don't need actually to move data, each of our data center contains data that is geographically located. So users that are in that area are not going to travel that often. Even if they travel, they're not going to damage the business if we just duplicate them. So what happens is that we keep the data into the Hadoop databases, and then what we do is that we generate with Hive a lot of tables, and that causes problems because what happens is that when you generate tables, you want to be sure that all these tables are consistent. You don't want to have like a table has been generated 1 hour ago and table now, and then when people watch reports and say, oh, numbers don't match, and the reason is because they've been generated 1 hour apart. So this is actually the part where we are working and generating reports, and this takes all the time from 1 hour to sometimes 16 hours. We have some processes that are very intensive, especially a lot of machine learning that we use to compute which one are the info about the user such that we can recommend the best ad. And also we have information that we run in real time. Of course, when you're running ads, you have things like a frequency cap. You want to be sure that you're running on pace, etc. And so what happens is that we're going to have two paths. We're going to have a fast path where we have data that has a smaller granularity, and with this data we want to make it very actionable very quickly. And the other data where we can take some time, we produce time at the right time in the way we can monetizable.
Why don't you say a little bit about how you get information out of the analytics system into the real-time system, sort of what tools you're using there?
So what happens is that
Frequency of
the
updates.
analytical system definitely does a lot of things. There are analysis that we are just doing it, I would say for fun, just to discover what happens. Oh, look at this user. This is happening. It's actually interesting. And sometimes we discover new things about users. We discover new things about our interaction between ad users and so what happens is that we generate data real time, and then what happens is that we gotta make it actionable. And the way we make it actionable is definitely we are not using any of these solutions, and this is where actually we're using Aerospike, because we need to have information about the segments for users, and then what happens is that we upload on Aerospike. But another thing that we're doing is that we need to have information about frequency caps and things like this. Now, in the past, people relied, and I mean, we still do it. We rely on cookies. No, that actually, I think it's the largest distributed database in the world. I don't think anyone can say anything against that. But the problem is that it doesn't really work. No one loves cookies, and you are at the point where if you're working server side with other partners, you cannot rely on cookies, or these partners can't. So what happens is that you need to have real-time information about this user you need to be able to provide. And this is where we need to have the speed, the latency, the low latency. And we run, I think at this point we are running 4 of your instances, 40,000 in operations a second, just for this particular task. Yeah, I think I got lost somewhere.
Okay. So maybe you could speak a little bit about So you've got you're importing a fair amount of the data in real time
Yes.
out of Hadoop, and that's going to creating audience levels, right?
Yeah.
Can you share a little bit, maybe, since so many people who are in advertising, scaling an SSP compared to scaling a DMP, compared to being on the buy side? Do you think there are any particular challenges based on Pubmatic's market position?
Well,
or is it really just all the same, and the problems that we've all got?
I mean, some yes or not. Okay, definitely some of these things are symmetrical. Okay, so what we are seeing and we are doing is symmetrical what the DMP is doing. So we and actually sometimes we are doing exactly the same thing, like synchronizing cookies. It could be initiated by the SSP. It could be initiated actually DSP, not DMP. Okay, so sorry about the confusion. So. I mean, we definitely have the higher throughput, and we need to take decision in real time. Whereas I think that the DMP doesn't have this limitation. Definitely we're going to get affected more by the publisher if things are not done in real time. So I think that is one of the biggest difficulty of being on the SSP side. And you're really going to be able to serve something and do it in very little time and take all the blame for everyone that is on down the ladder from there, depending if it's another partner, etc. So the thing is that when he was saying you need to make an impression in 120 milliseconds, it's the SSP responsibility. Then you can have other parties that might take longer. It's your responsibility still to be sure that you're within the boundaries and you're not taking more time than is needed. So I believe that is where it's the problem. And then you got to work an architecture behind it to be sure that all these components, where they're connected together, don't have this problem. And I don't think you have as much of this problem if you are on the other side of the fence. Great.
So you talked about switching from Java to C.
Yeah.
Can you tell a little bit about what GP mentioned was you've got slow C, you have to find a way to make it go faster. How does that roll out within your company when you say, well, there's the bottleneck and it's still already in C? What's next after that?
I read it somewhere before I started studying computer science that it's sometimes it's not up to the language, it's more up to the algorithm. And I think that people, when they think that they're writing C code, they think that just the fact that it's C, it compiles in C, it's fast by definition. And I think that people are totally ignoring all the good sense of writing code in the right way, or using the right data structure. So I believe that what I see a lot is that people just write C, but it's like very widely, and there is, I should say even at home, I think it happened in every company, you will figure out that people start writing a lot of C, but it's not really the good quality. So I believe that there is always a little room of improvement. When there is not, definitely you got to watch out of the box. Instead of trying to shrink, what do you do next? Do you write assembly? You start writing an FPGA? I don't think you can do, although I think that there are people that are proposing to do that, to do algorithms in FPGA. And probably you want to find other solutions, and they're probably there. Sometimes it's just laziness that you are working on that, you want to just improve what you have, you don't want to rebuild. And sometimes it's just you're dealing with the business, and it's hard to justify them that that something needs to be rewritten. I don't know how you guys did from Ruby to Scala, from Scala to C. I think someone would have killed me.
So I know one of the things that we do internally at Aerospike in those moments is also employing more pair coding. We have some pair coding advocates, and if there is ever a question of was the algorithm just designed quickly as opposed to well, when you start pair coding in those environments, you'll tend to want to show your pair.
Pair coding. I'm actually a very big supporter of pair coding. I think that first of all, when you're pair coding, you have another person, you have your pride of writing good code and show him, look what I can do, you cannot do, and vice versa. So in a way, it's you're putting people on the race. So I believe that this is very important. And on top of it, the other person is trying actually to fail you. So I believe this is actually a very good point. On top of that, two brains, you can always find a different solution. And if anything, I'm always to check solution out of if the problem is there, concentrating too much on the problem is not taking you too far. It's better if you start thinking of other ways of approaching and solving the same problem.
So one last question. Why don't you talk a little bit about your scale metrics, which metrics you have found, which specifically, is it network latency that you look at, is it server utilization, CPU? What have been some of the most important ones in finding bottlenecks and being able to achieve your business metrics?
Well,
I know they're all good.
They are all good. I believe the latency in this business, it's some of the most important one. Throughput, etc. You can come. It definitely is important, but getting that without latency is a big problem. I'll tell you that because we work with publishers, and the first thing they measure is if there was any impression that took longer than a certain time. Oh, I found that there was a spike where you guys served in 30 milliseconds instead of 3 milliseconds. So I think that this is actually one of the things that we need to check more. And usually latency hides for many of other problems, because if you're already designed for latency, and latency still happens, that means some of the other things, throughput, etc., are going to get affected. You might need to go back on the drawing board and figure out how to fix it.
Great. Thank you.
So thanks.